Okay, in the previous video, we were trying to work with this integral here to find a solution to it. And we used long division, and we got it expressed in terms of these two integrals. And this one here is still pretty complicated. We wanted to see if we could factor out this denominator in terms of its prime factors. So you have x to the fourth minus 2x cubed is 2x squared minus 2x plus 1. And if you've seen the videos that we prepared for the video series concerning synthetic division, you know the way we go about this then is take the coefficients and basically go through trial and error. Say we want to find out, is x minus 1 a factor? So then over here we write plus 1, and we write it down here, and then we add and multiply. Minus 2 plus 1 is minus 1, times 1 is minus 1. This becomes plus 1, times here is plus 1. Add these two, we have minus 1, plus 1. That's 0, so you can stop right there. That means, yes, this is a factor. So this is one of its factors, x minus 1. And right now it's x minus 1 times what? Bring this 1 down. That now is the coefficient on x cubed. So this is x cubed minus x squared plus x. Our new constant is 1. X cubed minus x squared plus x minus 1. So write it here. Now we're looking for, see if we can break this cubic expression into prime factors. Again, we write down the coefficients. X cubed, x squared, x to the 1, x to the 0, and the coefficients are 1, minus 1, plus 1, and minus 1. Let's see if maybe x plus 1 is a factor for this part. So here we write down minus 1, and we write it down here, and then we add and multiply. This would be minus 2, times minus 1 is plus 2. This will be 3, times minus 1 is minus 3. That's not 0, so forget it. Before we go on to higher numbers like x plus 2 or x minus 2, let's see, we didn't try x minus 1 yet. So, erase this. Let's see if for this part, will x minus 1 be a factor. We've eliminated x plus 1. So if this is x minus 1 here, now we write down plus 1. And again, we write it down here. And we add. This is 0 times 1 is 0. Add these together. This is 1 times 1 is 1. Add. We get 0. Yes, this is now a factor for this. So we're going to have for x cubed minus x squared plus x minus 1. This is a factor. X minus 1. And x minus 1 times what? We'll bring this down. This then is now the coefficient of x squared. So we have x squared minus 0 times x, and the new constant is 1. So we now have, this is x cubed. This is equal to x minus 1 times x squared plus 1. So finally then, putting all this together, we can say this is equal to this times this times this. So let's make some room here. So this is equal to x squared plus 1 times x minus 1 squared. Times x minus 1 quantity squared. Okay, well that's encouraging, because now what we can do is, for this integral here, let's do this step by step so we don't make any mistakes. We have minus 2x plus 4 divided by this, x to the 4th minus 2 x cubed plus 2 x squared minus 2x plus 1 dx. Let's see, that's going to equal the integral of, this stays the same, minus 2x plus 4 divided by x squared plus 1. Let's write this a little bit neater. X squared plus 1 times x minus 1 squared dx. Alright. Perhaps we're making some progress. We started with this complicated integral, did long division, we got these two integrals, and we were able to factor this denominator into this, and here it looks like we should be set up to apply partial fractions. So let's see, how would we go about doing that? Now we're going to have minus 2x plus 4 divided by x squared plus 1 times x minus 1 squared, and that's going to equal, this is a quadratic expression, so that's going to have to be ax plus b over this quadratic expression. And again, we explained this in our introductory video on partial fractions. And then let's see, this is a linear factor, but it's squared, so we're going to have plus another constant, call it c, over x minus 1. And then we have a plus another constant over x minus 1 squared. And we'll call that d. So now we have to multiply both sides of the equation by this, and then set it equal to that. So we're going to have minus, let's see if we can get it set up on this video anyway. This will equal ax plus b times x minus 1 squared plus c times x squared plus 1 times x minus 1 plus d times x squared plus 1. Yeah, these are going to cancel, so it's d times x squared plus 1. Okay, now what we have to do is multiply all through and collect terms, and then see how that compares to what's on this side of the equation. And we might be running out of time to do that in this video, so come back. We'll pick up from where we are and see if we can determine what A, B, C, and D are. So come back and let's see if we can get this finished.